Good afternoon, everybody. Welcome once again to another best practices training from Next Gen Cam. This one is for PowerMill, as every second Friday of the month we do our PowerMill Next Gen Cam best practices training. This week's going to be a short best practices. We're going to cover the composite curve tool and the usages and just basics of the composite curve tool. Just as an overview, this was kind of a request from some customers that would like to have a video that they can reference different aspects of the composite curve tool on. This is also going to be a recorded webinar on my side of it, but we will have question and answers based on some of the other team members here. So feel free during the webinar to still jump in and ask any questions. And of course, you can send emails and anything into us as well. So within this short little webinar and just covering the using the composite curve tool, we're just going to cover the composite curve tool creator as a basic function and going through each of its functions as well. We'll do use cases for 2D and as well as doing a use case at the end for the flow line toolpath for the embedded curve, which we'll cover within our curve types. So we're looking at embedded curve patterns that we'll be creating with the composite curve tool, as well as spline fit and arc fit as we go through the different selections that you can force. There'll be some tips and tricks in there on the surface selection itself, as well as the edge selection and guidance. That way you can kind of see kind of what works really best. So hopefully you guys can pick up a little bit from this brief Next Gen Cam best practice video. Now the composite curve can be found either within patterns. When we create a pattern, we can of course create a composite curve directly here within the edit panel of the pattern. It can also be found anywhere in the right click of both the patterns and the boundary if we go into the curve editor. Now the biggest distinction between the boundaries and the patterns as far as geometry creation goes is that one is of course closed segments, which is the boundary, and the other is open and any geometry, which is our pattern technology. We call it a pattern so that we can drive toolpaths to it. From the pattern side of things, we'll be taking a look at driving toolpaths along a curve on our example part here, such as we would around a contour at the bottom of this part. When we go ahead and create our pattern, again, we can come in and in the patterns, we can right click on our pattern and go right into our curve editor, or we can come into our composite curve tool here. When you enter the composite curve tool, it will automatically be within the curve editor in PowerMill. So there you see our environment changed at the top of the screen. Once in the composite curve tool, you'll see the flyout appear that basically controls how we're going to extract the edges across the part. Before we dive into how we do this, let's take a look at some of our settings here. To start things off, let's click on an edge, then the edge we want to extract. Now what happens is PowerMill assumes a couple of things within the settings to drive this curve and how we want to extract it from the model. Those controls you'll see are found over here on the right hand side. This is of course, the curve kind of direction and what type of curve we'll be pulling out of the surfaces, as well as our options. Now, if I open our options file, which is the wrench of the screwdriver here, that takes us into our options within PowerMill, and you'll see within the curve editor under composite curve, we have a few things that we can do. Now, by default, we're going to have this follow edges only option here, and that should be checked for the majority of things when we're going into the edge extraction of surfaces. This can be unchecked if you're going to be trying to follow kind of internal lateral lines within a surface, and you can of course extract those as well. The important things that we see here within here are gap jumping tolerance. That's kind of where it sees minor gaps within the surface connections and decides that it can run along those lines or edges automatically. Maximum angular discontinuity. Basically what we're looking at here is kind of where it flows across the surfaces at an angle. Now currently with our defaults set the way they are, our fitting, which is kind of our edge extraction type, is set to embedded curve. All right, now this is important because mostly we're looking at creating embedded curves if we're using toolpaths such as flow line or even a driven toolpath for a curve such as a pattern toolpath that kind of embeds the pattern as we extract it with the composite curve, and this should be your default. And then we have our direction at branch point. Now this is by default set to kind of a straight option, which is also very much like a tangent option. And you'll see within the edge that I've selected here, the red line indicating that's the line that I've selected. You'll see a blue kind of star, which indicates a start point. And you'll see some arrows indicating a possible direction and then a tangent direction. So the pink colored line indicates the tangent direction, and the yellow colored line indicates a branch point that we could actually click on to change the direction of that point. I'm going to cancel out of the options here, and I'm just going to use one of the options here. You'll see some other things show up within the composite curve toolbar here that now they have lines selected. I have different things that I can do. I can back step a single step. We can also rewind to the beginning, basically erasing what we've already done. The very far left icon that you can see here is basically a flag for your surfaces. What this does is this helps map out the surface directions, and this can be handy if there's multiple surfaces gathering in one area, or maybe you have a point such as the top of this radius here where there's multiple curves or lines that we could possibly branch off to. This kind of helps us get a plane kind of marker on the arrows, right? So turning that on just gives us a little added visibility to the markers themselves. If we move down the line, what looks like VCR controls are actually different things that we can do. We can reset it, of course. If I hover over that, you'll see we get a pop-up. I get a define start point marker. All right, so instead of a pause sign, we're looking at a start marker there. I get a rewind, basically to the beginning. I get a back step, which is a single step back, forward step, fast forward, and then an end point marker. Now when I select an edge at the very bottom, PowerMill automatically assumes that tangent due to that straight option that we've selected there in the drop-down. Now if I go ahead and just select play forward, you'll see that what's going to happen is the edge extraction is going to follow that kind of pink predicted line direction all the way around the part. Again, that's staying straight tangent. And if I were to hit fast forward, it's going to try to extract that edge all the way around that part. Now you'll notice that it's hesitating around some edges. There's a few things happening within the composite curve tool that decide whether or not it's going to extract the edge on the upper portion of these surfaces, on the boss, or on the floor surfaces. Now it's a good idea, and I'm just going to go ahead and reset this all the way. It's a good idea to blank the surfaces that you want to see or focus on with your composite curve out. And the reason we would like to do this is so that we can focus our selection on that. Now I'm going to go ahead and exit out of our pattern, select that bottom surface. I'm going to hit Control K for this so that I can blank accept. And then I'm going to go back into my composite curve editor and in the composite curve tool. And now I'm going to just select that bottom edge. Now, since there is no other solution to the selection, PowerMill selected the entire edge for me. I didn't have to fast forward or hit the play button. So if you blank out your selection and you have a complete chain along that straight option, then what PowerMill is going to do is it's going to grab the entire thing for you without having to go through and step through the selection. Once that's selected, I'll hit this record button, which will create the pattern. And then I'll hit the check mark to accept the pattern into my project. With the composite curve completed here, it is important that if I am completely done with the pattern itself, I still need to hit the accept finish within the pattern option in order to accept it. With that pattern created, let's go ahead and take a look at a couple of other options that we have. I'm going to go ahead and unblank all of my geometry before going into a new pattern. And we'll create a new pattern. And then within that pattern, we'll go into the curve editor for the active pattern and come back into our composite curve tool. Let's go ahead and take a look at some of the other options within our selection here. Now, the embedded pattern creates the geometry quite well. However, if there's a lot of maybe breaks within the surface, or maybe there's more points that need to be created to create a curve versus straight lines and arcs. Now, you can force these options by just simply selecting these other options to extract the curve to. One of them is to create a spline fit. That's going to actually create more points within the curve because it's going to fit the spline to your tolerances more. I'll go ahead and demonstrate that now. We'll just change that and go ahead and select the same exact line that we have. I'll reverse this one so that it's going in the other direction. And I'll just fast forward it. Since it's tangent, it'll run across those lines. And again, you can see the benefit of blanking your surfaces. I'll record it, hit the green check mark, and this time I'll turn on the instrumentation. And what we're looking for are the amount of points, since this is basically forcing a spline creation to the pattern. You can see all of the different tolerance zones that the spline had to add to the contact point of the edge of the surface. I'll go ahead and accept that pattern. We'll go ahead and create a new pattern. And in our third pattern, we'll go ahead and turn our geometry on, go into our curve editor within the right click, and we'll go into explore our other option, which is forcing the arc fit option here. All right. We'll go ahead and select that, reverse it, and fast forward it. We'll accept that pattern, and let's take a look at the instrumentation on the pattern and turn off our model. So you can see that there's less points to it and more arcs created along the curve. So that kind of forces the curve. Now these patterns are not embedded, which means they're not actually attached or part of the surface itself. So they do have that minus side of it, but if you're looking for more clean curves or arcs with center points along whatever geometry you're extracting, that would be the solution that you're looking for. Let's create one more pattern to take a look at our last option. I'll turn off the light bulb on the previous pattern. Let's go into the curve editor and turn our geometry back on, and let's just create our composite curve, go right into it. Let's change this to the polygonization option. So what this is going to do is create segments of tiny little lines within the tolerances on the edge of the surfaces. All right, so let's go ahead and just click on that polygonization, click on our edge to quickly create that, and just show with the instrumentation how many more segments we get within that option. Now, that's the purpose of these selections. If we go into the composite curve and look at these, this just gives you the option on how we want to extract and create that geometry. Now, this has, depending on your geometry and what type of curve you want to create, this gives you different methods and different solutions for you to use. Now, use case, I'm going to say that our first option within the curve, and I'll go ahead and just accept that pattern to get out of it, and I'll activate one of our first patterns. Turn instrumentation on so we can take a look at it. So the embedded pattern curve with the single surface is going to be one of the better ways to get a clean curve out of this. And toolpath wise, what we're looking for depends on both your machine tool, its look ahead function, as well as the toolpath you want to create. For our final example, let's turn our geometry back on and unblank everything. Once again, we'll create a new pattern. Let's go into our curve editor, jump right into our composite curve tool. So we're going to basically create a pattern that we may want to follow around the edge of a component. Let's say around this bottom edge of this surface, and this pattern would be more for a flow line toolpath to stitch the radius of this surface onto the part. Now, just as an example, I'm going to go ahead and change this pattern direction here, and I'm going to go ahead and give it the dominant left option and come and click on that surface. Now, what you'll see is by changing that arrow to the dominant left, instead of following the line and continuing tangently through it, it's now switching and selecting that left. So as we go through our selections, you can control the direction, how you want this to pull and extract the edges. I'll go ahead and reset this and change my type. For the flow line toolpath, it is important to know that you do want to have the embedded curve option. I am going to change it to the last option here, which is stop at discontinuity angle. And again, we have that set, I believe, to 45 degrees. So when I select my surface, it's kind of looking where that directional change is going to be. Now, what happened with this is that since it didn't change at 45, it's kind of choosing to bypass 90 degrees altogether. So it's not actually seeing that, and it's passing through it to the next curve selection. All right, since that isn't what I want, I'm going to go ahead and back that up. Reset it. Change that back to my tangent, which gives me more selectable options in my opinion. And then kind of my last tip for this video is going to be always kind of create a start and stop point. So if I select this edge and I use the fast forward button within the composite curve tool, it's basically going to make its own decisions from this point where it can go and where those branch points are going to stop. Now to demonstrate this, I may need to fast forward this video. The fast forward button can be quite dangerous because as we select that, it's going to decide where it can go. And see, now it's gone all the way around my model and I have to actually wait for it to come back to my start point. And unsuccessfully, it's chaining around the entire model to get back to my start point. Now, depending on your geometry, this could take a very large amount of time. I've seen some of them get hung up on hours of calculation with this. I'll go ahead and rewind that. So it is important to give yourself a start and stop point so that the curve knows where to start and stop. Again, these little pause markers on the composite curve dialog here are our start and stop points. So if I wanted to start here, and let's say I wanted to end at this point here, I could then place those markers. So I have a red on my first marker and a blue on my second marker. If I select any of those edges, PowerMill knows where that edge extraction is going to be, and then I can simply record that edge. I'm going to go ahead and select the bottom here, and since it's starting at the wrong place, we can reverse this. And in this case, I can just simply select the pink area that I want to end at and record that. Now I have a second curve. So for my flow line toolpath, I'm going to need an embedded pattern that gives me a start curve, a finish curve, and the long curves that I want to follow. So I'll go ahead and select my next. And in this case, since it has many ways that it can go, I'll pick a start point at that key point or end point, and then I'll grab the end point on the other side. If I just select in between there, it should give me the most logical route for the geometry that I want to select. And then I can record that. And finally bring my last pattern and record that. And hit the green check mark once I'm happy with it. I'll go ahead and show my instrumentation. And you'll see that the embedded pattern creates many curves along those surfaces. However, as it's successfully embedded, I'll go ahead and activate my 1/8 inch toolpath. From my Home tab, go to my Strategy selector. Under Finishing, we'll go to Flow Line Finishing. Select our pattern, and you'll see that since we broke the pattern up and had it selected as embedded, I will actually get a valid pattern with both a start point and a stop point and my 2 along curves for this toolpath. Let's go ahead and change this to 2-way. I've got a couple of settings I should change here. Let's up our tolerance a little bit for our finishing. Let's also zero out our thickness and maybe change the step over a little bit just to get a closer step on such a small surface here. After that, let's go ahead and set some leads and links. After we set our 2 ways, I think I'm going to go ahead and link this together via some arc moves. So let's go circular arc with that. We'll apply a constraint. I'll just give it a little bit here for the skim move and of course our safe move by default. Then I'll go ahead and calculate that toolpath. You'll see as the calculation starts to calculate and resolve that the flowline toolpath calculates to and from the embedded pattern, and the embedded pattern was completely successful on the calculation there. I get a nice clean toolpath along those curves. As long as I've broken them up utilizing the composite curve and selecting them individually, flowline seems to just work right out of the box. Again, one of the things you want to keep in mind is that we do have to reselect our pattern often to get that validate pattern. So it's not just going to be valid right off the bat. You're going to have to actually use the drop down and possibly reselect the embedded pattern. With that, I will go ahead and turn everything over to Mark Wietrich and Rob Walensky for the Q&A portion now that the video is completed. Thanks once again for joining me and taking a look at this best practices. And as always, you can send things into our support at nextgencam.com. As well as ideas, please feel free to throw some ideas out there for future best practice webinars or future webinar content in general regarding Autodesk CAM, and we will try to accommodate. So thanks once again.